Alright, howdy folks, and welcome to NESnet. This is day number 10. My name is Paul. I go by InfiniteNesLives online. And we are making a Wi-Fi NES cartridge to help bring homebrew NES games online. We've made a good bit of progress over the past 9 days of effort. So we have a cartridge now. Well, we actually have two, but the one wasn't working great. But I've got this guy with lots of logic spare on the mapper, and there's our little ESP001 module, just because it's easy to connect up and starting with the bare bones. So last time we were writing 6502 assembly for the first time. We should so we made our routines that will send data to use the 5001 status register, and the 5000 register is the data register to get data on and off of the ESP, which bangs the data. So the current build, where we've got socket serve running here, and if we so right now we send gamepad 1, the first player. If I hold a direction, this first byte is the state of the controller. So anytime that changes, it sends my local machine, whichever IP address we configure, the state of that controller. Then we also got data back. I'm trying to remember. There was a I think it's just we have the controller being variable number 0 in our 64 incoming bytes, and so if we write to the first variable, then I think that'll show up. So you can't see it very well when I don't have it zoomed in, but right there we have controller 0, first controller, and then the second controller would be to the right, but the second controller is the remote player. So in the socket server, I think we can, so we go UDP or send, I think it's to UDP, and then the message. So we write variable number and I think we just put 0, and then we say what we want to write it to. ASCII A. Got it backwards. Send protocol client number. Oh, client number 1 probably, or 0 rather. Here it lists clients, client number 0. Okay, it sent it. Didn't appear to show anything up. How did we have that? So I think our routine variable number 0. So it compares it. If it changed, then we list it. Why isn't it changing? I don't think you're supposed to put the message in quotes. Yeah. So we can't really. I need to take better notes or something. Go back and watch my own videos during my videos. I don't know about that. Let's see. So our NESnet routine, or I'm sorry, our assembly routine is just getting I'm 100% sure that I have the right build running. No. I think we do. I guess we can also do this. We can try to read. Although whenever I change the controller, it's going to be sending data. I don't know if I want to bother with that. We got rid of our debug messages in the ESP. Maybe we should just add those back. But it was, what was the deal? Oh, wait a second. Write variable all WVA, and it just does everything. This build is 409. Let's just go ahead and rebuild this. What are we gonna? No, because I'm sitting in the directory. drag drop box off here. So, because that was one thing that we had a problem with last stream, was not calling our actual routine, but that, let's just flash the cartridge quick. File sizes are different. By 16 bytes? Yeah, okay. One thing that we need is some means of testing if the ESP is awake yet. There's probably some dumb ways we can check that, but the test ROM actually locks up because it's waiting for a reply that never comes. Oh, that's different. I must have swapped around my ESP. Wait, what? Before it was putting it at the variable 0 is here. It was putting it here. Maybe I had the wrong. I had a stale build. I don't. That isn't making sense. Anyway, let's try to. What's the deal? This is silly. There we go. You can see 41 now, which is ASCII A. So I guess we had an old build there. What? I don't. Whatever. Not sure that happened, but it works. Okay. So we need to. God, why won't you minimize? Come on now. Doesn't want to minimize. Anyway, all right. So let's figure out a solution for it locking, a way to figure out if the ESP is awake. So how is it locking up? Okay, what's happening is the very first, it always goes, if the gamepad didn't change, it doesn't, if the gamepad 1, right, player 1 doesn't change, the local player. So it only actually sends it if it changes, but We don't really want to do this until it's booted up, but it's not. Unless you push a button quickly, this is not where it's locking up. It's locking up here to get the second pad from the ESP. And that routine, so we load A with 0, that's the variable number we want to retrieve, and then we read ESP variable. So status register bit 7 is set. And we're waiting for it to clear. So here's our process. To read a byte, so we have to wait for bit 7 to be set. Bit 7 being set tells us that we're allowed to write. Now I don't actually know what state that bit starts up as. Probably clear. That is actually in the, it's actually in the CPLD. The W bit is supposed to be starting upset. Maybe we want to actually start up with a clear. When the CPLD boots up, you're not actually allowed to write to it. And wait for the ESP to set that bit. But what I'm thinking is the best way to communicate if the ESP, like at the very first power on. But then part of it's like, how do you deal with reset? So my thought is when the ESP starts up, it could just write a value to the SPI register at boot. And that would be the console's indication of, you know, if the CPLD starts up with the SPI register all F, the 6502 could just keep polling 5000, waiting for it to be a specific startup value. But how do we handle reset then? Because if you reset the console, the ESP doesn't reset. Maybe we should come up with the reset command. If this bit's actually starting up set, which supposedly it is, and to some degree after a console reset or something like that, it's probably end up getting set as well. A write is going to be allowed most of the time. If you wait long enough, it'll should eventually be set anyway. So I don't think this is actually where we're getting caught. It's actually here where we write to, so we write the command and then we're waiting for the ESP to respond with data. It never responds because it wasn't paying attention prior to it initializing itself. So without changing any of the ESP code, we could just have some sort of timeout on this 5006 being clear. So on initialization, we could have some version of this routine that times out, and if the ESP timed out waiting for a reply, then we can conclude that it hasn't started up yet. If it's responding, I guess we could just do a timeout for both of these, for the W bit and the 6-bit. But if it is responding, we'll just use some sort of like parrot echo command or something like that, I guess. And then that, or we could have really we could have like some reset command where on startup, to cover first power up, you'll have that delay. It keeps trying. If it tries like for so many frames, then we could say, oh, there's a problem. But otherwise, if it's a reset and you're just sending it the reset command, then it's probably the first time it's going to respond and it'll reset itself. We have to actually come up with some sort of reset routine, but so these routines read and write the ESP variables that we came up with. But we also have messages implemented. So here's our commands. we've got instruction set to some degree. Bit 7 always of the command is whether it's a read or a write command, what we're expecting for the subsequent bytes. Bit 6 is set for this immediate access to the variable registers. So we're not actually, this command that we're coming up to, like a reset command, we wouldn't use these variables. We'd have a bit 5 set if it's a long command, or the next best is rainbow like, or wait, the next bit 5, yeah, long rainbow. And then special command, or the command is in the lower nibble, links are predefined. This is basically what we want. So it's a special command. Do we have any processing of this? We don't have any of this in the ESP right now. But I guess we should make this. We're gonna want stuff like this. Trying to remember where that documentation is. There's some other commands I was wanting to. I guess to some degree one of my ideas was this message code. So we support messages. The message buffer is 1 KB of RAM. And you can set so this just lets us send long messages. But one of my ideas was you could have this pointer to a different block of RAM that's like metadata. But really the only concern I have for implementing this special command is bloating our interrupt service routine. But we could conceivably handle it in the main. So let's see, where would we? Here, so if we're in opcode mode, if it's a variable command, else, we're assuming it's a message for now. I don't think we support. Is that how you do else if in C? I think so. I'm not used to doing else ifs in C. Come on, just tell me my answer. Yeah. So if it's a special command, the command in nibble or defined length so we'll set this bit for a special command. And then we could have up to, we could either have 16 commands, command 0 through 15, defined by the lower nibble. I guess we could expand this to where if it kind of depends on how many of these we're gonna need. We may not actually need that many, in which case 16 may be plenty. But if it's not, we could say, like, if the command is F15, then the actual command is in the next byte. So it's pretty easy to extend. Now, since we're in an interrupt service routine, what we probably want to do is just store the command and set a flag and then handle it in the in the main. Now normally we would set command mode to data because we get the operand here. We're in opcode mode, and then we would get the operands. But for something like these reset commands and stuff like that, there isn't necessarily, somewhat easier to not have an operand. So when the NES starts up, it can just keep sending this reset command, and it's not waiting for a reply. It just pulls this data register, and if it gets the expected response, then it can, then the 6502 knows that the ESP is operating. So for now, let's do that. So the command equals command already is set to data. So this is the opcode that was fetched. It's equal to data. Command is set to data. So command is already set. really, if we want, we probably want like a global command. Really we want a mask though, because okay. I have to actually make those variables and do something about them in the main. So here's our, this is our main loop. This command flag must be the message command. So in reality, we can just have a switch. Is it case or switch? Jump around too many languages. Okay, so switch on the, and then case and breaks. Yeah, okay. So switch on main command, and then curly braces, defaults, breaks. Okay. Case. Something like that. Yeah. All right. So we need to define this command reset. So we should just be able to do 0. Part of me says we should do something more special than 0, but because it, well, whatever, it starts up as 0, but all right. So if we're gonna reset, whatever, I guess maybe we should call setup, but it should have already been or we could have our own reset is special in Arduino. So we need to indicate somehow to the ESP that, or I'm sorry, the 6502 that we have completed reset. We could write a special value to the SPI register. Normally we wouldn't want to just blindly write to the SPI register. Because what if the 6502 thinks it's allowed to write to it? It would stomp the value. But this situation is kind of special in that it's a reset case. The NES is somewhat expecting that the ESP might not be listening. So we'll want to call send SPI byte. We'll just do a normal write. So to some degree, this command is defined as expecting a byte. sends by byte. So does this compile? What is all this? I don't know if I want to update. Let's build and see what happens. Missed some curly brace somewhere. Where's my curly braces messed up? This seems good. Oh, I guess we want to clear the command flag though. Just thinking if we didn't want to for the default case to indicate that it wasn't actually processed, but would just be indicating to ourselves. To some degree, we shouldn't be accepting more commands until that's processed, but all right, where's my error? Unknown command received. 584. Is my switch wrong? Switch, curly braces, case, expression, statements, break. That looks okay. What are you? Expected primary expression before. I wonder if I messed it up earlier. Expected semicolon before close brace. Forgetting a curly semicolon somewhere? Oh, I think this is my... Is this... It's a constant expression. Maybe. I mean, nothing should require the break. How are you doing, Zorge? Like, break is entirely optional, right? Did I, like, misspell default or something? Am I an idiot? Well, don't answer that. Or I already know the answer. You don't have to tell me. Default. Yeah, let's try. That's good, man. Let's see. It really doesn't like that. Maybe. Okay. Was that really the problem? Or did I like forget? Did I write the file halfway through writing it and it seems to require something. Does it not? Does it? If there's no state, it wants a statement there. What if we just do that? Yeah, I guess it doesn't like default if you're not actually doing anything, which I guess makes... What if we... Because for cases don't require a statement. Because you can like stack multiple cases on top of each other. But default requires a statement. Yeah, this is saying no break is needed for the default case. I don't know. It doesn't make sense to me that it would require a statement. What if we just put... It says it's expecting a semicolon. We put a... Effectively saying it's requiring some sort of statement, but if we put a nothing statement, then it's interesting. I mean, I get that, like, why have a default if there is no statement, but syntactically it doesn't seem like it should be required, but whatever. So let's flash our ESP here. There's nothing much to see really. I just got my little serial to USB to serial adapter thing that comes with the ESP01 modules. So flash this guy. Now we need to write some 6502 to do something about this. To do something with this information. So we could test with the INLretro. Might be a little bit faster. And it's good to have these tests for the INLretro. So let's Alright, sorry. Our thingy is programmed. ESP. So what are we going to do? We're going to write So we're going to write to 5,000. I guess we're just blindly doing it even if it's not set. We should technically be checking if 5001 is set. Let's just get it working though. So which bit? This is effectively the special command is the reset because it's 0. So hex 10. And then so while what? Does not equal A5. So I'm just going to read. time sleep. We'll sleep for half a second, or maybe 1/10 of a second. So it'll just keep doing that until we get something. Maybe have a timeout. Try that. So the cartridge isn't plugged in right now. It's just gonna keep trying. It eventually gave up. Can't see my light. Is it awake? There, finally. We need to try less often or more tries. Let's do every half second. Well, it responded. I guess that's a good sign. It worked. There it is. It takes a few seconds to start that guy up. Oh, but it seems like we did a bunch of other random stuff, and we might have sent it commands that it couldn't process. Where this stuff is old test code. Let's just comment it out for now. See, it's not. We should be able to keep sending the command. Yeah, okay. It's just the test code that we had put the ESP in probably in a command state waiting for more data or something. All that code was before we implemented a lot of this stuff. Okay, so it seems like it's working. The hardware is working, so let's write some 6502. So I guess we'll just we'll send the command once and we'll check for the reply. We won't know. We'll have to interpret the reply to figure out if it was successful. So A5, right? So we need to send NESnet special and reset command. So let's don't bother waiting for W to be set. We're just going to write the command. So LDA so we'll write it to 5,000. And I guess we're just going to, here's part of the problem though. We write the command. There's gonna be some latency for when the ESP interprets it. So maybe we're better off checking the 5,000 register, and if it equals the reset value, but how we just don't want to get, I want to make sure we send the command at least once. Because what if we go to reset and it already happens to have that value in there? just gonna make a to-do for now. So I should really define these registers, but whatever. So we're actually returning, if we sent the command, then we're returning with the command that we sent. If it is the reset value, then we're returning with the accumulator being equal to I guess anyway, I was going to say that the read bit, the R bit, would be clear if the response was there. Maybe we should be checking that, but so we just won't go to the main loop, I guess. And the way that we'll see that is whether the gamepad is displayed. So we're just going to sit in a loop. So this is not necessarily going to check every frame. It's going to sit in this loop forever. So maybe we do want it in the main loop. And let's do that. I guess really we need our own NMI weight. What do we want to do? So PPU update waits until the end of the frame. Okay, so if it's equal, we're actually going to jump to the main loop. So branch equal otherwise we're going to GSR PPU update So this will sit in this loop and it'll only exit when the reset value is found. Okay. $123 trailing garbage. Semicolon. All right, let's flash that guy. We don't really need to do that, but whatever. All right. So I have a little, you can't really see it, but I can. I have a little, the LED on the ESP turns on when it's actually booted, but if I just, we shouldn't actually be checking the controller data. and displaying that until the ESP actually awakes. So that's kind of our indication on the NES. My cursor is not doing anything. It seems like it's not working. So I'm not gonna push anything. I'm gonna wait for the LED to turn on. Okay, the LED is on. It doesn't seem like the code is actually getting what it expects. A5, right? Yep. That's where things get tricky because we don't have an emulator. Well, for the most part. We could use an emulator to step through our code that's doing what we think it is, but we could just print the value that is seen on the screen. So we jump to ESP reset. ESP reset reads 5000. If it's equal to the value that we're expecting, it will return. If it's not equal, it'll send the reset command. Now maybe I'm not actually sending the reset command like I think I am, but this should just be it looks right. So for now, let's oh, wait a second. Wait a second. No, that's right. Hey, Strager. Just once, as far as I know. Oh, wait. It's working now. What? Did I just not wait long enough? What if I reset? Because my cursor should be blinking. What is working? Reset. Nothing. Because even reset should be trying to do this, and it should be eventually getting the value. I don't know what's. So it eventually starts working. But why is it taking so long? Because the ESP's already and I'm not sure if I reset it, it eventually starts working. Better than most things can be. Yeah. If I don't touch anything, does my cursor just start blinking? Because my cursor doesn't start blinking until it gets into the main, but I mean the gamepad's not even being pulled right now, so I don't think me doing anything with the gamepad is going to change anything. The cursor's underneath the, I can make it a little bit bigger here. The cursor's underneath the P and pad there. Never. I don't know. What if we power cycle it? I feel like the cursor, like, I feel like the cursor actually blinks there. Like it's getting a false positive. It's not getting hung up in the beginning. Probably just want to go ahead and display it, but let's look at this code quick. Yeah, you can't see that, huh? Wait, reset. So we jump to the subroutine, we compare with the reset value, we branch if equal to the main loop. Oh, that's not a, it shouldn't be a branch. Or, yeah, no, it can branch you. Yeah, that's right. Let's just go ahead and display it, because I don't get what's going on there. So my display function here is little. I have a subroutine for display hex byte, and you just load the X with the X position and the Y with the Y position in the accumulator. Where's that function? CPU routines. Yeah. I feel like that routine should be in my display. Like how the RTS comment. Oh, does it? I probably changed the routine and didn't change the end. Yeah, let's fix that. Gamepad. So to display something, display a value. We can just use display hex byte. Is A corrupted though? Yes. LDX. So I don't know. I don't know where that's going to be. $15 is where do they put the gamepad? So we can do more like 10 on the X. Controller row is 10. 16. 12, 13, 14, 15, 16 should be, so let's just do 17. So that'll, when we're sitting in this loop, that'll display. Yeah, that's exactly what we're doing. The only thing is I mean, at least tell us, give us some information here. But I'm not like persistently displaying it. It's just after we check it. So we'll know if we got an A5 or if our logic is dumb. Okay. Let's see how we did. Boom. Okay, 0, 0. Now the LED is still off. Okay, it's on now. And it still appears locked up. But it never got A5, so it shouldn't have kept going, but I don't know if my logic's actually right. So what if we reset it? It's still zeros. I still don't know what's going on. And 00 doesn't even sound right. It should be the command that it sent. I ANDed the bit that indicates this addressing mode and 0, 1 and 0, 1 0 and 0 is 0, so we sent the wrong command. I do that nonsense too much. So why it started working, I don't know. I don't know. Maybe but I never did an earlier one. I never actually sent the reset command because this is just checking. But if I don't know why it would just start. I really don't know. Mystery. Did I flash it? Did I make it? Cosmic rays, yep. All right. So we're getting 1 0. It's still off. Okay, it's on. Got A5. Now my cursor's blinking. Okay. All right, sweet. So, all right, take care. 5000 is the ESP and not RAM. That's correct. Well, it's technically a register that's inside the ES or the mapper. So you can, I mean, it's kind of like 1 byte of RAM inside the mapper. And I just don't know what would have got that specific value into that register. It's intentionally not. But maybe I didn't actually make the first write like and it wasn't consistent. Well, like sometimes it seemed like it was, but that value got in there and then it just stuck. I'm going to take a quick break. I'll be right back. And we'll continue on here. That's a lot of time for one command. I don't know. Maybe we'll try to talk to the server. I don't know. We need to have like more metadata and stuff for connecting to Wi-Fi networks, which server to connect to. I don't know. We'll see. I'll be back in a minute. So, what now? Our reset function is pretty worthless right now. Although I wonder, can we just reset? Yeah, it seems like it's okay. It immediately responds with our blinking cursor, and it's getting a 5. We want to do other, like we should probably clear all of our registers. It's just the number of things that have to be. Well, we might have some sort of timeout or something on the ESP that causes us to reset ourselves. So these things we may want to just go ahead and clear. I don't know. Let's go ahead and reset our variables though. So it was incoming and outgoing. Anyway, there might be other things we want to do. Command mode and stuff like that, but all that stuff has to be proper to get here unless we have the ESP implement some sort of timeout. So I kind of want to implement our own server. I've got a local machine set up running Debian that I'm SSH'd into, and I also have one in France. Well, it's not mine. It's Sylvan's, and he's the guy that is working on the Super Tilt Bros, and he's got it's a virtual VPS or virtual public server, or private server. Anyway, so we can test stuff locally and in the world. My goal, I'd like to be able to support peer-to-peer for least amount of latency. But some stuff, even peer-to-peer, it's going to be helpful to have a server to find other peers. So this server would be relatively basic, but it would just be an IP address that we go to either known IP, or we could use the one thing we don't right now. The IP address of whatever we're communicating to is hard coded in the ESP firmware. As is the, so here's a server IP address. This just happens to be the IP address of my local machine, this actual computer I'm streaming from. These things would be good to have the NES configure. This is a bit, give it some metadata that the NES can configure. Coming up with a way to key that information into my NES is a little bit annoying, but maybe we can do it relatively easily. I mean, we could hard code it in the NES for now instead of me typing in with my controller every time. I guess that works. We could also test that with the INLretro. But so we also need to tell it which network to connect to, and the password. That could just be, I like having that hard coded in the ROM for now, in the NES ROM, because then all we need is a way to insert our input into just a controller interface or whatever. So maybe let's just do that. How do we want to do that? Part of me says there being metadata that we can point our message pointer to stream data. Stream data is probably the wrong word, but we already have so message mode We only have a single byte command for now. I forget how that worked. So if it's not a variable, it's not a special command. It's message mode. If write is set, we were able to read multiple. Anyway, so okay. So the first byte is the opcode. It doesn't have any of these set. So it's the default mode. But when do we exit? So we go, the command gets set, then we're in data mode, and we set the index to 0. Once we're in data mode, so I think the first byte is supposed to say how long it is. I don't remember. I need to better document this for myself. So this is variable command, and this is message mode. Okay, so rainbow mode, the length is in the next byte. Medium mode, it's in the lower nibble. So but where's the actual? 256 bytes. I think the message buffer is actually that's only incoming. So this is an incoming message from the server. We copy over the incoming packet into our message buffer, and we set the pointer. So this is incoming. And here's how we read it. Data main, this is from the NES. to some degree, those don't have to be separate things, but that's how it. So what I really want is just a generic way to update data, whether it's a message buffer or metadata or whatever. So right now, these are hard-coded to a 256 byte buffer that the NES writes to, and then the ESP sends out to the server or other device. And then a message buffer that incoming packets from the internet get copied over to, and the NES can read from them. But the process so that's where part of me says, well, let's maybe have commands that change this pointer to point to metadata or buffer. And then that would make it so this stuff would be more generic and not fixed to a specific value. Or a specific location, a specific buffer. It could be anywhere. But before I go hacking this up, I don't want to break it, so we need better means of. The way that we tested it was manually writing to the 5001 register. So maybe we should just go ahead and implement some of these. We actually write 6502 that tests some of these things. And we'll see them here in socket server. So the controller data tests the variables, and I can write data. This is the incoming array, and the NES updated controller 1 to ASCII A. This is variable number 0. We want to write it to B. That didn't seem to work. Why doesn't that work? Oh, I think it's space. Yeah. 0. We want to update it to B. There it goes. So it doesn't actually, it's just overloaded. So it updated it, but this is the controller byte. Let's put a copy of this in there. And this, I mean, ultimately, we're using socket server right now, but for the incoming, maybe we can start working on the server for the other direction. But let's go ahead and work on the 6502 code to send a message. That was all manual before. So that is not the right code. So message mode in medium, the lower nibble is the length of the message. Now we'll make this into more than just messages, but for now that's what we're doing for moving, for writing up to 16 bytes from the NES. So now I guess we can just go ahead and do it. This should really have a so let's send a medium message. To do that, couple different ways we could do it. We could store the data on the stack. It's only a media message or whatever is maximum of 16 bytes or whatever, so it's a relatively safe value length to put on the stack. The stack isn't overly fast. I think we'd be better off to use pointers. So we could have data strings in the ROM, or it could be in RAM. We just use a pointer and then like an index register for the length or something like that. I have pointers. Let's just use pointer 0. So pointer 0 maybe we actually want to have it in the accumulator. I don't know. We'll see. Do we want to have like error checking if it's too long? I don't think so. Doing something useful with that. Ultimately, we could have some other, I don't know. Let's just get it working. So these, I'm just thinking, I don't think it's going to be helpful to try to make a really generic way to write different commands. These things that we're doing are heavily defined on the command themselves. So having a different routine for each of these is going to make it faster, and they're not very big in the first place. So it's going to be similar to this. The command itself, now here I have it hard coded to C0. That should be this NESnet write, NESnet var. this is really read is, if I set it up this way, then I could change the polarity of that bit and the code shouldn't change. We should go ahead and make definitions so 5,000 . Just assume that works. Okay, so I have these branch if W set, branch if W clear, these macros, because remembering BMI and BPL and BVS, BVC is a little difficult. I don't think I've actually tested these though. Yeah. Maybe let's just verify our build before we get too far. So that'll sit there displaying 1, 0, which is the reset command, until the LED is on. A5 looks good. Make sure that we can, that looks right. Can we send data? We write variable 0 to A. There it is. Write it to F Yeah, that's ASCII values. You can barely see it there, but that's where it's getting written to. So that all looks good. Let's go ahead and change our BPL. So this is branch if W clear, which should be W branch if W clear. And that's supposed to be BPL W clear. So if it's clear, we're going to spin. And then BVS, branch if overflow set, becomes branch if R is set. I guess that was the only place I had it. Do I have a... Hey, Kutsu. Good afternoon to yourself. So we're digging into the 6502 code. Trying to replace some of the things that we were manually typing in with the test ROM before into the 6502 code. Having fewer things hard-coded in the... But so right now, what I really want to get to is... Oh, okay. Anyway, for anybody who is just jumping in, what I want to get to is not having the IP address of the server or whatever machine we're talking to hard-coded in the ESP. I want the 6502 to be able to communicate that data, but I don't really have a way to write that metadata yet, but I have a way to write other data. So getting that, having the test ROM be able to test those things, and then I can start giving us means of changing the metadata and know that I'm not breaking other things that were previously working. Okay. And this is just me trying to adopt my handy macros. So this, to some degree, it would be nice to have macros for this whole thing. The only thing is that my macro needs to have labels, needs to have unique labels, which shouldn't be too hard. I think you can just set a scope. Anyway, let's get this working and then maybe try to make better macros. So the command is LDA NESnet write plus NESnet medium, which anyway, so we'll leave it as this to try to help make it easier to change, even though it's actually zeros. But so we're going to write a medium length message. And so we write the command, and then we're going to spin in a loop to write the message. So if we use like the Y or the X register for the length, then we can use that for a counter, and we could actually do an STX or STY here instead also. We do want to make sure that we're not sending longer messages than we can support, but let's go with X for now. So if we're going to write the maximum, it's a 4-bit value. Just try and remember if I said that if it's offset by 1, because why would you write a 0 length message? Wait data going to have an issue. Oh, that's a good point. So let's go. Yeah, so here if I'm gonna write, and I don't know if we ever tested other variables, but if the incoming value of the accumulator is supposed to be the variable number that we're updating, A does not get preserved in this process, because one of these days I'll master the bit command, but probably not any day soon. Let's check that guy again. Bit sets the Z flag as though the value of the address were ANDed with the accumulator. The S and V are match 6 and 7 of the tested address, and that's what I'm using it for. But what's the other effect? Oh, okay, so it isn't actually changed. The accumulator is, the value of the accumulator will affect whether or not the Z flag gets set. So it's, if you wanted to check if a location in an address were like specifically the value A, right? Then you would LDA, or A is probably a bad number, the value 55 hex. So you do LDA 55 hex, then you would do bit of whatever location, maybe it's 5,000 for example, and if it's equal to the accumulator, then the Z flag will get affected. Exactly how it's if it were ANDed. So if 55 and the value, so if the value were 0, the result is 0, and it would get ANDed. It would get, the Z flag would get set. Still don't. Is often used to skip 1 or 2 bytes. Yeah. Let's what's the explanation here? It performs an AND between the memory location and accumulator, but does not store the result, which is good. And I think we'll be okay, because this subroutine, we're expecting the accumulator to stay preserved through this, and we're fine. We're really just wanting to check if bits 5, we want to check bits 6 and 7 of the 5001 register. So we do a bit test on 5001, and then we can branch based on the V and the S flags to check if those were set or clear. So that's really all I'm using them for, but I hadn't thought about what else the bit command is. So we should be okay, because I don't care about the Z flag, but now I'm curious to better understand the bit. Yeah, okay. The Z being set by the result of the AND operation between the accumulator and the memory if the result is 0. So if you wanted to check a specific bit or a specific few bits, if you want to check if bit 0 was clear, you would do like an LDA 1, because the 0th bit is set. Then you do a bit test, and if it was set, that memory location and the accumulator would not be equal to 0, it would be equal to 1. So you could do a branch on the Z flag of it being not equal. But if it was clear, then the result would be 0. Yeah. So it's not too crazy, but yeah. So that's, but I hadn't thought about the accumulator, but it is preserved, so we're good. Okay. So, the number of bytes, though, In medium mode, the length of the opcode is in the lower nibble. Data index. So it gets set to 0 when we start enter this mode. I actually set the first byte of the array and then we increment it. And then we check. So if it were 0, if the command were set to 0, the length were set to 0, we would actually send 16 bits, I think. Because we post increment. Yeah, so entering this loop, the index equals 0. The first byte that we write will get stored. Yeah. So the only thing is writing 0 how are we checking if we're done? If zero is an invalid value here, it won't actually send 16 because the index will be set to 16, which will not be equal to 0. 16 is because the index has more than 4 bits in it. So let's just write that for now. Document it. Yeah, which I mean makes sense. If I set it to 1, then we're expecting 1 byte of incoming data. It doesn't make sense to send 0 bytes, but we could maybe use 0 as a special. So 1 through 15 is valid to do use yeah, so we'll stick with that for now, but we could use it for some other special case. So it does literally, if we want to send 1 byte, or the max is 15. So in the main, we'll do an LDX. Let's go ahead and do the maximum. We need to set the pointer to the data that we want to actually send. Row data, read-only data. I think I'm just going to put in the top of the NESnet for now. So test message. Oh, we could do ASCII. Where do I? I have ASCII Z PPU data as an example of that. Yeah, for my controller strings. That's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, 1 by 15. Okay. Oh, that would be nifty. Although I want to make sure I want to specifically write one that's 15. But anyway, okay, so this is 15 character string. So we need to set our pointer. LDA. Oh, right. Subtract the previous label. So, test message. Like that. I always forget. I want the lower byte. Yeah. I always forget how to do that. I wonder if I'd be better off using .low byte. I just always forget the syntax. It's identical to, so I think I have it right. It just feels unnatural to me. So pointer 0 low. I forget what I called that. Yeah. LDA. Yeah. I think I have a macro. Yeah, move a pointer. So we give it the pointer 0. Test message. Like that. But I write code like this and then people don't have my macros or whatever, but basically the same thing I have there. Okay. So pointer 0 is set and we've got the length. Transfer X to A. Oh, actually, unless pointer high isn't, it better be. I think that's how I have it defined. Yeah. That's just how just definitions that I gave myself for ease of not being dumb about Indianness. So this technically we don't need this because we do need to set the write bit, so I guess the best way to do this is transfer X to A, or with this. We do need to set that upper bit, so now we can just enter a loop. So the first thing we need to do is wait. Oh no, we need to, yeah, that's right. We need to wait for the W bit to be set. It would be convenient to have that in a macro. Not to think so hard about it, but anyway. Here's the thing though. Well, let's just do it. So we'll have to do an LDA pointer 0. if we're going to be decrementing x, then we're writing it backwards. Which programmatically is convenient if we store things backwards, or better known as Little Indian. Well, depends. Oh, hold on a second though. So we yeah, no, so we can use the Y register. We don't want this. This is more for table haystack, not go. We actually want to use the Y register, but I might still if we want to support my test message is literally just a string. Reasonably, you want to write it in order. So to really do that, we have to clear y. We could keep incrementing y and decrementing x as a counter. Oh, Tobor Prime coming with the raid of 16. How we doing? What are you working on or playing today? This is slow, but I think we're just going to go with it. We don't have, so we can just LDY 0. Lots and lots of tile sets for a game we're working on. Nice. What system or platform is modern platform? Mega? Night Knot, how we doing? So we're I can show you the cartridge here. We've got a NES cartridge with a little ESP8266 Wi-Fi chip on there, a tiny little antenna on there on the PCB. Anyway, on PC, this is if it's tile set though, it sounds like it's retro themed, perhaps retro in spirit. We got the retro hardware here, so we've got like 5 different code bases going on to make all this work. The ESP code, the little microcontroller on the sticking on that pigtail there, is written in C or C++, and that's where all of the Wi-Fi stuff is going on. Oh, stick X and some temp variable in 0 page, then increment compare y to the temp. Yeah, that's probably a good call, Koetsu. Oh, there you go. Looking forward to using the NES maker set. Very good. So right now we're working on the 6502 assembly. We're just trying to, we already verified that this worked a couple of weeks ago, or a couple months ago, I guess now, on the ESP side, but we're manually typing things in with the gamepad. So we're just going to have it show up here on my local machine running a little basic server. So yeah, so Koetsu's suggestion, so here's the, it's more convenient for the 6502 to decrement counters, because then you can just compare to 0. But I guess the alternative, and this is kind of what Koetsu is saying, store the length in a 0-page variable and then just compare increment, because we can use indexed y addressing, and then we can just keep incrementing y until we get that value. And in that case, which I pretty much agree with here, I think it's using the X register isn't actually that convenient, or doesn't save us much. If we end up wanting a 0-page variable, then this is kind of the structure that I use the first several bytes of 0-page, and I think of them as registers or arguments for functions. So what we can do is we can say argument 0 is the number of bytes to send. And in that case, we'll do LDA 15 STA arg0. Now, arg0 is, we can compare against that. We still need to clear y, but instead of, technically we called it with arg0 and the accumulator set. Anyway, I don't really want to do that unless we like wrap this function call in a macro or something. So simple yet so limiting. Yeah. Well, and you really gotta understand your tool set to really get it as optimized as you can. So let's see. That should all be good. So now we can just increment y. The first time it'll be set to 0. And I'll copy byte 0. I'll increment y will be 1 if I had called it with y equal to 1. So we want to do a comparison of y with compare y to arg0. I don't normally make very good use of. I try to avoid compare y and x and decrement them and rely on them being equal to 0, but let's just get it working, and maybe we'll want to change it, maybe we won't. But here's part of the thing though. Is this actually doing what we want? No, we still haven't written the data. Here, so we'll write the data right away because we have to wait for the W bit to be clear, and when it is, then we can write the data. Then we can do our checks to see if we're done. To some degree, this is a good time to have code. The 65 or the ESP takes some time to process the write. So rushing back to this hurry up and wait isn't that value. So compare y and then branch not equal write data. So that effectively will subtract arg0 from, if they're not equal, then we're going to keep going and write more data. Oh, y lda sta. Oh, yeah, there. However, well, let's just try not to get too fancy, but as soon as, the reason that I did that and my mind went there is, as soon as this is satisfied, we finish this wait, we can write the data. So to some degree, it'll be beneficial to load it beforehand and won't actually get, accumulator won't get corrupted here. So we should be able to do this up here. After this write happens, it's going to take a little while for the, it's only a handful of microseconds, but it's going to take a little while for the ESP, or yeah. So we increment, yeah, okay, I think this is good. So let's go ahead and build that quick. And flash it. We don't have an emulator, so we gotta flash the cartridge. You can see it down here. I got my little USB INLretro programmer. Same type of kit as your NES Maker Software board. All right, flash that guy quick. It actually takes a second for the, so right now it's, you see that 1-0? That's waiting for the ESP to power up, and then, oh look, we got something. It doesn't look right. Oh, you know what? I think so. I got tricky with my test ROM, and I think it's messing me up. because we received a datagram. Blah. I think I know what's going on. So I have character maps because my tile set where'd my messing go? There it is. Yeah, use .byte. But then, oh, but you know what we can do is we can, we'll have to put quotes around each letter, but you can see in my, actually I wanted the, so in my CHR viewer here, you can see I remapped. So hello is tile index 25 for H, 25 hex. Let's see if 25 hex is a dollar sign. No. Percentage sign, which is what we got right here. Yeah. So my char map messed it up. I wonder if there's like these char maps, I assume they come effect if you define it afterwards. Hey, Great Tech, how we doing? Oh, no problem. Oh, there you go. Yeah, no, that's fine. We're actually working on some of the stuff that will, to some degree we're getting pretty close to being able to implement your Twitch chat client, but the server and stuff is hard coded into the ESP firmware. So we're trying to move in the direction of not having that the case. So let's do what I'm wondering though is, can we just define my string before the char map? I think char map respects scope, but right, it just remaps the ASCII Z. Need an NES keyboard, yeah. Although I thought about it, if you got to get connected in the first place, but if your cartridge has a Wi-Fi ability, everyone in the target audience, for the most part, is safe to say, has a laptop. I guess to some degree you could do it on the phone, maybe if you made an app for it, but if you have a computer with a keyboard, you could have your desktop or laptop or whatever connect to the cartridge and send keystrokes, basically just like make a terminal of sorts. If you can connect your computer with a laptop, with a keyboard to your NES, then why does the NES need its own keyboard? The ESP32, which is the second generation of ESP, has Bluetooth. This simplest one doesn't, just has Wi-Fi. Oh, char map is ghetto compared to old DOS assemblers. It seems fancy to me. Yeah, that's kind of what I'm thinking. Let's do this though. Oh, you don't need to do it to each character like that? Oh, I can just do... Can I just do that? Appears so. Well, that, yeah. I resisted your suggestion for byte because I thought I'd have to do it like that, but it appears I can just do that. We'll see. Oh, there. See, my test ROM waits for the ESP to wake up, but we don't actually need that if we're just flashing the... It looks like we still got the wrong thing. Yeah. I don't need it. I don't think I need a trailing null. I'm not expecting it. I'm just... Well, the ESP adds the trailing null. Yeah, it seems to do everything. So let's... and I guess to some degree... This is my actual file, isn't it? Yeah. Can't find it. Is that my string? Yeah, that's what I'm thinking. what's just want to make sure I'm finding the right. I guess I can look in the mess and find my label. Scopes with a segment in char map with char map. Then I'm thinking, does it, if I just move my test string definition before the char map, or I scope it. Let's see. But I want to see where my test message is. Oh, I guess I could do switch to disassembly view. Oh, I can't see it there. Anyway, there it is. So 25 is my char map because H is tile number 25. But if I want it to be ASCII, then H is 48. So let's see. So here's where my char map is in PPU data. I'm wondering if I include read-only data. I guess I'm moving the location, so but it should be at the beginning almost, after my bank table. I can look it back up in Messen. Already defined, did I not write my there we go. Okay, there it is. So if it appears that if I just put my true ASCII strings before my char map, then I'm okay. So let's go ahead and flash that sucker just to what I really need is the ESP to be able to update my NES ROM so that I can build in wirelessly. That's really what I need. Okay, did we get our message? Hey, back at you, ESP. So 5, 10, 11, 12, 13, 14, 15. Yeah, 15. Yeah, and the null terminator is actually here. So if I sense that I'm at the end, I add the null terminator at the message is actually longer, but from the NES that's what it is. So that seems to be working. It would be nifty to be able to say hello back from the server. And this should already be implemented on the ESP side. Figuring out the timing though. So I guess Koitsu, what's up? So yeah, let's stir LAN. Hey, look at that. Function accepts a string argument. Oh. Accepts the string argument in braces and evaluates to the length. So you can just do the following macro encodes the string encodes a string as a Pascal style string with a leading byte length. Oh. I hesitate to click on your Stack Overflow. It would be nifty. I guess we're trying to move on before I even really... We were going to come back and... So, let's just go ahead and try it. So it should end up being... Oh, okay, I get it now. I was thinking that I was confused why this macro does that. Okay. Yeah. I was wondering, okay. So, yeah. Let's just steal that guy. let's see, where are we going to put this guy? Let's put it. Let's put it at the bottom. Old Pascal bastard. The C style strings, sometimes better, sometimes worse. Yeah, and the convenience here for it can make our function call simpler if we expect a Pascal style string, because we just load the first value for length. Yeah. What am I doing here? Oh, I was copying the comments. Yeah. So like this. PS or P string. Okay, so let's just compile it and look at it quick. Oh, what'd I do? Did I mess up my... Where is it complaining? A colon, semicolon, colon is expected. Oh wait, am I being in... What am I doing? It wants a semicolon? Oh, wait, my macro might be... Is my... Yeah, my macros are down here. Yeah, there we go. 0F15. Hello there, ESP. So I think it'll be it'll simplify things. So we don't need this. I guess the only thing that I wonder is may not always. I don't know. It's nifty though. Yeah. Right. So in that case, LDA point. Oh, we need to clear the Y first. So we load the length. Well, I guess we could do this. We could, well, hold on a second. We can just offset it. Oh, yeah. For some reason I was thinking we didn't have that. LDA. I think you're right too. Let's just check. Doesn't look like it. The only, yeah. I was right, but I was not sure. All right, LDY 0. Yeah. CMOS, man. So that's the length. Now we can this isn't a constant. That's the only, that's we with this setup we do need a 0-page variable. And we have to copy it in there. Part of me says that we are to some degree better off. I feel like the most times when we're going to use it, it's not that there's just some random message we want to send, but I don't know, I guess it depends upon what we're doing. If we're just setting some variable like the IP address or something, part of the other thing is this is limited to only 15 bytes, so not very useful strings. Just lets you get the length easier. Yeah. But for cases like if we're setting the IP address, part of me wants to change this though. Can we yeah, I guess. I was thinking of being 0 padded, but you don't. I'm actually using it as a string. The ESP does. Which is definitely variable, but it's not even, is it even going to be long enough? It could be 4 times 416, which is too long. But I was thinking you wouldn't bother sending the periods. You would send 3 digits per. So this would be 192.168.001.250 is how I was imagining storing the, but reality it's just bytes. Really it's just 4 bytes. Right? Yeah, once it's network packed and coded, it's always 4 bytes, but ASCII varies. And for reality, I feel like the most convenient is going to be use case, like depending upon what you're actually doing. I kind of want to go back. Well, here, I mean, to some degree, it doesn't really matter because Yeah. But here's what I can do. So yeah, it might be, but I'm wondering if we can we don't need a 0-page variable if we do the let's go back to this. So LDX, let's try to use the X register. So we can have we can do an increment Y and a decrement X and then a branch not equal. Well, couldn't you use it here though? Oh, but it's a label. Hold on. So we'll use the pointer to be the first, and this is kind of like what you were saying before. We'll load X with the test message. I'm going to transfer X to A, or in the command bits we need. Clear Y, and X still equals our value. Instead of this, we don't have to compare here. We can just decrement Y or X. Branch not equal. If we want to transfer 1 byte, it starts off as 1. We decrement to 0. Branch not, yeah. Because we're yeah, I think that's because if we came in with it equal to 1, we would want to send 1 byte. We would decrement it from 1 to 0, and we wouldn't branch, yeah. So this way we don't actually need a 0-page variable, which is nice, I guess. It's probably a little bit faster. See, then you can use the Pascal style string, but it's just how you call it. The function itself doesn't change. let's give that, make sure that works. Something doesn't seem right. It sent, it got in the wrong addressing mode. We broke something. Did we transfer X to A, or with write of medium length? Did X actually equal 15? Oh, this is not immediate. This should not be immediate, right? Because I literally want to load X with the byte at that address. Okay. My pointer. This macro might have messed up. Test. I wonder if I need. Before we compile that, let's just. Well, that's going to sit in that loop forever. What does the disassembly look like? I should be able to. Send. Oh, we would call that though. Oh, well, maybe we can just set. Let's set a breakpoint here, and where's my reset ESP? Set a breakpoint here. Can I cheat and say A5? And then that doesn't actually But let's see here. So pointer 0 is set to 8141. Where's my... That sounds right. So maybe my loop is bad. We're going to sit in this loop forever. I need to clear the, or set the negative flag. We wrote 8F, that's right. We're sending 15 bytes. Load Y. $44. That's why 44. Pointer 0 8041. Why is oh, what? Why is that? It doesn't make any sense. LDA why does it say it's 44? Because what did it sent D, which is hex 44. So why is that getting, it's, oh wait, it's off. It's not 8141, it's 8041. It's pointing here. It's supposed to be pointing here. Yeah. So my pointer 0 is wrong. So let's try that. Wrap it in parentheses. Cheat. It's still set to 8141. It's adding 1 to the upper byte instead of adding 1 to the lower byte. Why is that? Let's do this. Because it's adding it here and it's adding it here. It's, well, let me look at my, this should still work. Dot adder. I'm going to see if that, part of the thing is I've got a macro. Okay. Yeah, in my macro. So this did work. I'm wondering if I just add parentheses in my macro though too. Because this gets expanded to +1. If I send in address +1, then that's what it does, which is, I want this. But if I put it in parentheses, I mean this works because it's saying it's the order of operation. It's taking the low byte and then adding 1, or the upper byte and then adding 1. If I just add those parentheses, does it fix it? It does here, but I'm not. I will take the opportunity to make my macro better. Deserves a comment in the code for sure. Yeah. Agreed. Yep, that worked. What about if I take these parentheses out? Because ultimately, I don't want to have to remember. But the parentheses didn't fix it here. It didn't fix it until I got it there. So let's make sure that that's still okay, that's good. It's actually more important here, but with their yeah. I wonder if I have other places like that in my macros, but yeah, Gotta be careful with those macros. I mean, it makes sense, but I don't know. To some degree, I'm kind of used to. I make heavy use of macros in INLretro, and I'm always. Lots of times I'll just throw parentheses in there for being unsure of how those macros are going to expand. There we go. I've been bitten by that one enough. But I haven't carried that caution into my CA65. All right. So yeah. Well, it's like, I think I know the order of operation, but does it know? Does it have it right? So this seems pretty good. Overall, it simplified things because here we're doing loading, we're copying using the 0 page register is more cumbersome. But here we load X, we transfer it, we have to clear Y, but we can inc Y so that we send it in order. First index first, and then do our comparison. Yeah. Yeah. Okay, so let's get a message going the other direction. The way that this is, okay, so I can actually I'm not sure about my poking and peeking because every time I hit a button on the controller, it sends controller data. So it might break things, but to send a message or to read a message, from the host, if we just send let's do something like this, message, and then I basically think of myself, my packet as having 4 it would be something like this. But the ESP to read it, it sends we have to get so this message buffer so we just do any read that we do, it's any length actually because it's just not a variable or a special command. Any length read, which we initiate by writing a 0, but I can't really do that by poking and peeking because my buttons do other things, which maybe would be helpful to turn off, but so we send a byte of 0, that's the command, initializes the pointer, and then we can just, the length doesn't matter. All the read command does is it resets the pointer, the message pointer to 0, to the beginning of this sends by byte. It just sends the next byte. Where are we clearing the message pointer? Oh, when a packet comes into the ESP from the internet, the message pointer gets set to the beginning of the buffer. If we just hit plus, I think we start reading it. If we start, let's just read 5,000. Doesn't seem to be. I think I'm stomping over it and can't really read it. Anyway, really, if you look at this, it doesn't matter what you send. It's the last thing, and if nothing else hits, it just returns. But you have to wait for the R bit to be set, though. Or yeah, clear. Because literally all this does is sends a byte of the message pointer and then increments it. So every time you read, more data comes out. So let's see here. The command it's similar to this, except it's always 0. Yeah, I mean we either need, really we just want to have a means of testing this for now so that we can add more features and get a heads up when something's broken. So only thing is, we need to I guess after the gamepad, if I push any button on the first gamepad, then I can just pull the message, or I can't necessarily write the message to the screen every frame, or it limits other things that I can write. But it presents a problem that we're going to have to solve anyway, is what do we do? How do we know when the ESP got a message? So maybe the real solution to this is the more long-term solution of maybe we want a command, another special command that is just a pull for incoming messages. A check for messages. The other idea is that we get an IRQ. If the ESP interrupts the 6502, then just anytime 6502 gets interrupted, we can go fetch the message. But ultimately, I don't want to rely on IRQs. IRQs are a nice feature, but we want polling and IRQs. And I don't actually have IRQs set up yet. So, yeah. So this will be a command. I guess it's a, maybe we should call it an S command for special command because it has that format. So pull for messages. The response, I guess, could be if there's a buffer, multiple messages came in, then how many messages are in the queue. Dealing with multiple messages is another thing, but 0, there's no messages. 1, there's 1. So then my 6502 code can just check, hey, is there any messages? No? Okay, I'm not going to get a message. Oh, there is? Okay, let's go get the message, and then let's point it to the screen. So this, it'll get the special command to some degree. I kind of want to give the 6502 an immediate reply, especially for something like this. I don't want to have it. The reset, it was one thing to just give a slow reply in the main thread of the ESP. But something like this, I kind of want to do it here. I'm thinking about using bit 3 to indicate whether it's a main thread response or an immediate response. Give us a means of keeping our ISR from getting too massive. I mean, there's a fair amount of code here, but half of it's comments, the other half's white space, or a third and a third. And only one of these things is happening on a given. I just don't want to spend too much time drilling down to what is the current thing. It's a bit hard to read, but I'm trying to keep this function in bookmarked, but keep it in RAM, so I don't want it to be too big. But let's just do that. IRS. Oh, and that's the wrong bit. So this is actually have to. So oh, it's my window. Reflection of my basement window off the CRT glass. So they're trying to clean my, because I can't actually see it from my angle. But if I get by ahead of the camera, then I can see it. So I mean, I can see when I look over there, but when I look at the TV, I don't actually see it. It's a perfect angle for me, not you. All right. So if it probably isn't a good idea. I'm writing code assuming that that's a bit. I do use the webcam. You're talking about my selfie cam? Oh, this camera is tuned for low light, so you can't see it. It's this guy. It's just sitting on top of the monitor. There's another one over here. You can't see very well. This one's pointing down on my hands. Or my... down here. So I've got two different cameras on top of my monitor. One at my face, one down here. And then I've got a separate one pointed at the CRT. So I've actually got three. No, it's just they're like I'll show you. They designed to hang on your. It's one of these cheapy. What is it? C615. See, right there. This isn't very good. Doesn't really show. See this guy, how it has a little, this kind of just hangs on the monitor. So it's pretty nifty. I mean, it's just like a cheap $30 webcam or whatever, but they work decent. They don't work very well for pointing at a CRT. I've got a better webcam for that. Well, the first one I got was a better one, the Kaio Razor or whatever. But don't really need that good. I mean, it's not that great, but it's like an $80 webcam. Yeah, I recommend. I mean, it's definitely not an expensive camera. The C615 or whatever I just said. Yeah, 615. And Streamlabs does okay with multiples of these. Here's my Razor. This one has a light. So if you, I don't use the light when it's on my camera, but for your face, I never really used it that much. But anyway, these ones did all right. No problem. I don't know if it will, there's like, you can run into problems having multiple of the same webcam and getting the settings for them. So that's why part is like, well, I'll just buy cheap webcams and hope for the best. It's not, and there is like one step up from the Logitech that a lot of people have. pretty common one. Okay. That's a slow command anyway. So if it's a fast command, else, what kind of hardware dev are you? Looking at streaming, we need more hardware devs. Let's see here. Oh, okay. So, are you like are you doing like modifications of originals, like making them wireless and stuff, or like arcade stick type stuff going for original Super Nintendo, or something else? Those are my guesses of type of stuff. I've converted quite a few Super Nintendo controllers in my day from kind of how I got started, from standard Super Nintendo to USB or to Wiimote, stuff like that. I don't do any of that stuff anymore, but that's how I got started about 10 years ago. So, okay, cool. Yeah. So if we're gonna process it here, to some degree for now we can I don't really like putting this code here, but I don't. If we want a fast reply, we got to put it in the ISR. I guess the only, like, if we don't run into an issue, and we don't run into an issue, but the only other idea is these could be slow commands if we coded them from the NES in the perspective of the 8266 is, well, how fast it is depends. So the microcontroller itself is running at 160 megahertz, which is like blazing fast. It runs at 80 megahertz by default, but you can overclock it to 160 and it does just fine. But this guy has no built-in flash. It runs on SRAM only, which is probably quite a bit of the reason as to why it can run so fast, is it's a SRAM only process. Most microcontrollers, you can overclock them quite a bit, but you have to keep adding wait states for the flash that you're executing off of because the flash is so slow. So like your speed of the microcontroller is mostly limited by the flash that you're executing from. For modern ones anyway. I don't know, in my limited experimentation. But if you execute from SRAM, then you generally don't need those wait states. The ESP, if you look at this guy, this is the microcontroller here. This is the flash. So the flash is SPI. It is quad. It does support quad I/O if the SPI supports it. It's effectively like an external hard drive for your or running code off an SD card or something like that. It has to buffer that code to execute into the RAM, instruction RAM, and then execute it. So because of that, well, it is memory mapped, but it's not, you can't execute. So it's, I'm not an ESP82 expert, but your functions are memory mapped, and it's like, oh, from what I expect or gather, if you say jump to address, 200,000, then it has some sort of, table. It's almost like it is a cache, right? The cache table is like, is address, the code at address 200,000 in instruction RAM right now? Yes. Okay. Where exactly jump and execute in that instruction RAM as it's there? Is it not there? Oh, it's not in instruction RAM. We have to wait. We can't keep executing. We have to buffer. We have to load just like your modern PC has to, if it's not in RAM, right? It's in the hard drive. It has to go get it out of the hard drive and load it into RAM. Your modern PC actually can't execute off of RAM either. I think it can only do it off of the cache. But anyway, your modern PC has like 3 levels: cache, RAM, hard disk. This has 2. Yeah. So yeah, that's this interrupt service routine. I think I can, I have notes. So this, I think I was just measuring how long does it take to bang this byte, and for 1 byte, when I overclocked it to 160 megahertz, it took 12.8 microseconds, which is equivalent to 23 cycles on the 6502, but not every instruction takes 1 cycle. A bit branch loop takes 7 cycles, so I was just trying to get a reference of how these loops, it takes about 3 of these. So you want the ISR to be small, so it's always in SRAM, right? And see my function here, you can put this pragma or whatever you say, this tells the assembler to put this function in, try to keep it in the instruction cache in RAM. But if I make it huge, right, then there's a limit. It can only be so big. But if I make it really big but still fit, then all the other code that I may try to execute has to get cached. And so, yeah, the reality of it is this actually calls other functions, which aren't necessarily, I guess to some degree that's kind of a way around it, where this function to send a SPI byte may or may not be in, yeah, pinned pages basically. This function may or may not be in SRAM, if it's not, it's going to take longer to... Maybe I'll just do that. Because that gets me the performance if it's cached. And I mean, maybe I want this function to be cached, but it's easier to tweak that. I can modularizes my code a bit and lets me move some of this stuff in or out. Yeah, let's do that. But at least this way my to some degree, some of this other stuff might make more sense to do that too, but so I guess we're going to get below this. Successfully distracted me, and it was a potentially useful tangent. What am I doing? That's not what I meant to do. We can still keep this idea of whether or not we actually use it. Okay. So switch command I guess really I want to switch command and mask So it's a special, no. Yeah, special command mask. Case. What did we call it? S command message pull. So if, how are we gonna know? Or let's just do this. So it's not actually, that's the wrong thing. I don't even think about it. It's just it's like saying or like fillers in your speech. Like I'm like, when I go to like think of what I want to write, I just :W. Send SPI byte. What did I put? SPI send byte. See, I can't. Sing plus makes you anxious. I don't. Oh yeah. There's a change that hasn't been written. So pending messages. Now we need to actually make that. Message. We actually probably want to go ahead and define it as a 8-bit value. If we're sending it, we don't want to create weird problems of having it more than a byte. So now we need a way to we could automatically decrement it, clear it for when a message gets read. I guess that's just what we'll do for now, but it's it's possible that, well, likely the convenience that of the ESP just being able to read the default command being to read the next byte of a message is if it wants to start doing something else, it can. You know, if it's reading a long message, maybe it decides it wants to do something in the middle. Well, it can pick up and keep reading that message, or maybe it wants to restart and read that message from the beginning. So maybe we want to give some, anyway. For now, we'll just handle it for it. But one way would just be to, I don't know. Really, the way that I'm thinking this would work is there'd be like multiple message buffers and, you know, read number this or number that, but I don't know exactly. If we're done though, how do we know? Because right now I just return the next, it can just keep reading. I guess it could just keep incrementing. But then the NES could tell the ESP, hey, I'm done. Or count that message read. But that does get messy for multiple messages, but we aren't even really there yet. But if there's multiple messages and the NES is like, oh, I want to read, you know, message number 0, count that, I read it, count it as read. Now I want to be interrupted, or I want to know if that gets updated. So maybe that is useful. Well, and I don't really this is all still undefined, but like we don't really know how it's going to be used or how we want to use it, but message 0 might just always be the latest message. If it's like, because depending upon how the game is running, you may your messages, maybe if 3 messages came in, you only really care about the latest one. You want the most recent data if it's just a copy of one after another. And so if that's how it's set up, and you're like, oh, well, mark that message as read, then the ESP can be like, well, the NES has its most recent data. I'll just let it, you know, inform it when I get more recent data. when I get new data. So with this setup, if I have S command mark red, it would get set here. Main command flag would get set, and then S command mark red. Yeah. In that case, we would just pending messages. For now, this is just gonna go from 0 to 1, 1 to 0. But that's kind of what I'm thinking. So let's flash this guy with our new firmware. Find all our compiler bugs here. Special command declared void. Did I not return or something? Probably. What? Oh, did I not? No, special command, special. I'm not returning anything. What are you getting upset about? These compiler variable or field special command declared void. Oh. Got Lua. That's what happens. Change languages too often. Okay, looks like it's good. So I should probably use the INLretro to test this stuff first. Is this guy gonna start up? There it goes. Back in my day, variables were int by default. Well, and I think it would here. It didn't make you declare what type of variable it was. I think it's more common. Oh, really? I wonder if where's my firmware? I suppose I closed it. The errors that I've been getting with this compiler are not what I'm used to with GCC for ARM. So it kind of throw me for a loop. I wonder if I have. I'm curious if I'm surprised that I haven't, like, it's not like a common thing that I do as much as I switch back and forth between Lua and C. All right. So let's go ahead and do this. We don't. I'm just testing. I don't need to flash it every time. Okay. So checking pending messages. So we write what's the command? It's 1 1 so 1 9. What did I do? My hands are getting cold. All right. Yeah, 0 pending messages. So let's send a message. Acknowledged. Let's check how many pending messages we have now. 1. Okay. Let's I think that's yeah, just 1. Okay. So we mark it as red and then we check. So, oh, we weren't actually expecting a reply here. Yeah. We didn't actually read it, but we acted like we did. So we send it a message. Now, to actually read it, that's like 14. Okay, so we have to read, and then it actually doesn't, we want to just write. We should be I'm just gonna cheat and rely on USB being relatively slow per transaction. It really drives me crazy that Lua doesn't have a minus minus plus plus. Okay, I gotta write this variable out twice. So let's send the message again. I mean, to some degree it doesn't matter, but we didn't actually print anything. Maybe I don't think so. Maybe it does, and I'm yeah. UML? I don't know what UML is, so I would say no. I don't even know what it is. It sounds like something management would want you to. Unified modeling language. Yeah. Well, you're just talking about logic diagrams or whatever you want, decision. Like, they're used quite a bit if you're talking about like in data sheets and stuff. If you go to like a Flash data sheet or something. Hey, D-Rocks. Not decision graphs, something else. Okay, they just look like those. Yeah, I don't know. Decision graphs all the time. Yeah, that's what those look like to me. We're doing pretty well. We've been going from one end of the code to the other, putting new functions in our commands in our ESP, and then writing the 6502 code. Yeah, structure of our program between modules, control flow behavior. Hey, Game Boy Link, doing pretty well. Yeah, I would say that, like, I mean, I kind of know what they are. Definitely not overly familiar with them or use them, but most of the code I write's low level. I'm wanting to, like, not necessarily interfacing with large libraries and stuff. Yeah. Part of it's like you can spend so much time documenting your stuff. At what point is that, like, and then you change your code and you need to keep that documentation up. Like, you have to be saving quite a lot of people time in your up-to-date diagrams and keeping them accurate to, like, make it worth that effort. So I imagine that it's for me, single dude doing things, not so much. But I can see how, like I said, it sounds like something management wants you to do. I gotta actually print this thing. Yeah, I mean, my comments don't match code, but at least the comments next to the code, you know, like, put this separate thing over there, like. Yeah. Bunch of zeros. Let's send a message and see. Hey, that looks like something. Did we? I'm interpreting it as a number. I want to interpret it as a letter. There's some. I think it's just. As soon as I see it, it's going to be. Professor made us spend 2 weeks making diagrams, models before writing any code. Oh. It's just like, okay. find Stack Overflow. Yeah, string.char. See, it's not actually there. It's interesting. I guess, oh, I'm reading past it because I only reset the message pointer to the beginning of the string when a new message comes in. Back at ya, S. Why is my pending messages? Oh, maybe because I read more messages than were actually there. So maybe we should have a check here. Okay, so let's go ahead and seems to be working. Yeah, you couldn't find it, could you? Try that again. Failed to write. Come on now. There we go. So now we gotta write 6502 to do that. It is pretty convenient to this testing these hardware or testing these new functions on the INLretro first. We need to read one more letter. Message 1. Although I'm not sure why. Oh, am I putting a... Oh, I think I'm putting too many spaces. Am I though? That looks right. 0, 1, 2, 3. Did I... I plus header length. Header length is 4. So we start at packet buffer 0. The first one is M for message. And then I start copying over index 4. So I skip over 1, 2, and 3. Let's do this. I think this is wrong to have 2 spaces, but what do we get when we read that back? Yeah. Oh, you know what? We we need to give it the command. We didn't give it the command. I mean, we eventually did, but we need to give it the command first. Give me the next byte, and then we read it. That's the problem. So we sent the message. Now, there we go. And let's try to decrement the message counter further than it should. Yeah, it just stuck at 0. Okay. So it was just our Lua test script that was not aligned with reality. I don't think we're going to get to working on the server today, but I do want to implement this quick. I'm going to take a quick break, and we'll see if we can't get this message printed out on the NES. All right. So 6502. We need to pull messages. I guess we can just do this at the end. Why do you do that? This get message, I think I didn't. Yeah, this is just me copying, pasting code before I had anything to target with it. So I guess the first thing to do would just be to figure out how many messages. I mean, we really only support one right now, but then getting the message, different thing. So what have we got? We've got message pull and mark read. So this one's actually, mark read is slow and message pull is fast. Agro Cool Craft. Goku Craft. How we doing? So we're you can see our NES cartridge here. Our ESP is nice and bright. So far we can send messages from the NES to my local machine. The NES said hello, and we're trying to say back at you and have it print to the screen here. So we tested it in INLretro and these Lua scripts, and here was our message coming back. Hey, thanks for the follow. So this new command should work. It seems to be working. Now we just want to do it on the NES. So we have to define our new commands, trying to keep things somewhat similar between the two different code bases here. So check messages. So first we have to wait for a command. Then we write the command so we're just going to figure out if there's a new message. The ESP will keep track. Really hard to find coders like you. Did you find one when you found me? Is that what you're saying? Or what are coders like you? So we're just going to LDA special command wear hats, wear many hats, game dev, HTML, CSS, PvP. Yeah, no, this little ESP can do HTML though. But yeah, I'm a low level guy. NES stuff, embedded hardware dev. Right now we're mostly just, really this is like embedded hardware firmware development so that an NES game could be built on top of it. Unity. It's interesting to watch people program games in Unity when I get used to thinking in the NES level. Wednesdays I work on my port of Always Awakening, which is a game that was originally developed in Unity by Eldon's Pixels, but it's NES constraints kind of. It was originally supposed to be an NES game, and then they aborted that plan and just went with modern. Yeah, there are quite a few. Well, of the people making games in Twitch, which is relatively small, I guess, when you compare it to the rest of Twitch, Unity is pretty popular. So, what's our command? I got mixed up here. So it's, oh, I need to add. Oh. Gotta put your beta game out there. So this, I should really have this be define the command as all of the bits. So and then when we call the command, we don't care about whether it's special or not. That's defined elsewhere. So it should only be here for coming up with the actual commands. That's a bit messy, but so NN message poll. Okay, so we wrote the command. Now we need to wait for the reply, which is supposed to be quick. Where's my read ESP vars? Like this. So wait, let's call this reply. So our command doesn't really need to be in parentheses. We store it. We wait for the reply, which the R bit of the status register will get set, and then we can read so if to some degree for now, I guess, we can just return to the main. Let's just print the number to the screen for now. Screen. Oops. Let's just put it on the next line, line 18. So, yeah, let's flash that onto a cartridge. Yeah, you can verify, could you? That's okay. So 1, 0, it's going to sit there until the ESP powers up, and then it'll give us an A5. There, oh shoot, something. The ESP is powered up, but it's, how do we break that? We keep getting hello there from the ESP because every time it powers up, it sends a message. But why is our reset command not work anymore? It's sending messages. Did we? Why did that stop working? Let's just try to send a message and see what happens. I mean, it should be displaying a byte here. It should have a number below the 10. But it's like it's not even getting there. It's probably not getting there. It is sending this message because we're getting it. Is it crashed? My gamepad's not responding. Seems to have. Now there's a good chance that we've got a problem here, but we should. The reset should work. And why is it sending a message if oh. So we're gonna say, so see here, send message. Send message doesn't happen until after the reset is done, right? However, this display hex byte doesn't actually happen. It doesn't show up on the screen until the next frame. So if we crash before we get to that next frame, then yeah, okay, so let's just do this. Let's just make sure that I'm not going to call my new function. You couldn't see that. Yeah. You could see some of it. Anyway, so I'm not calling my check ESP message. I'm just loading a value and then writing it to the screen for now. And then I must have wrote an infinite loop where the ESP is not responding. There, okay. So it starts up, it displays a number, it never goes and checks messages. Okay. So what happened? How did we end up with likely an infinite loop? Is the R bit not getting set? These are two different places where we could get an infinite loop. Now maybe we didn't send the right command. If we didn't send the right command and the ESP never responded because we sent the wrong command, maybe that's our problem. NN message pull appears. Oh, this one's supposed to be fast. Message read is not. That's why. So right, the whole point was we wanted to be able to quickly check if there was a message present. So we sent it message read command, and then we're expecting a reply, and it never gave one to us because it didn't think it was supposed to. It was right. Try that. Oh, but we didn't call it. Dang it. We fixed it, but we didn't. Try it again. I don't want to wait all that time. Every time I flash it, just go. Okay. All right. So we got a 1-0. It's waiting to start up. There it started up, and it checked messages. We have 0. Now it should be checking messages every frame. Really, it should only have to re-display the messages if it changes, but it's only 1 byte, so 2 tiles. So it sent us a reply. Hello there, ESP. Let's send it a message back at you. And it reports that we have 1 message. Very good. So let's try to clear that message. See, some of these functions, like, it'll be pretty easy to move them, but if it, really there's 2 different types. It's either we're expecting a reply or we're not. So we could move this into a more generic function where we send a command and wait for a reply, and then we just call it with the accumulator containing the command. Send command get reply. I don't know. So we just need to this I guess we should just go get the message. I was going to decrement it, but displaying that it's there and then it's gone, it's just... So if we wanted to send a command but have no reply, so that's it. Just whether it's useful or not, I don't know. JSR. I mean, if we're using this function a lot, you know, for different commands, then I guess. But whether or not inline, that function would be a lot faster. But we don't really care. Let's do this. Color codes do I use? For what? For my... I'm not sure what you're asking exactly. You're just talking about my highlighting for the code? If so, it's just, I don't know. I don't really know how to answer your question. There's this stuff in my vimrc or for this specific, for assembly specific stuff of highlighting. I can list out, I have all of the subroutines, or not subroutines, the opcodes listed out. So there's certain rules in my I don't even remember what it's called. It's not my vimrc, it's the file specifically for highlighting files of this extension. But it's kind of annoying because I write assembly in more than one processor, but I do STM8 stuff, I use different, but there's I don't even remember which one I use now, but Zorchenheimer, who was on here earlier, he was made a nice one, and I was tinkering with it, and then I ended up ditching it and just using a super generic one I found online for 6502 that was pretty decent or basic. But I do have it set up to where I add macros and stuff. I can have them highlighted in red or whatever. All right. My thought here. So let's just comment this out for now. Let's get the message. So, branch not equal not good. No message. So if there is a message, or branch equal, if it's 0, so how many bytes are we gonna get? Where are we gonna store it? Let's define a buffer in RAM. $128. Do we want it to be aligned? Do we want to rely on it being aligned? I don't know. Let's try to not for now. So we need to set our pointer. We're going to use pointer 0 again. So a pointer to where we want to put the data, and then we should try to remember PPU write string. So these strings, I think they're null terminated. ASCII Z for trailing 0. And that's what my subroutine relies on. We could just pad it with a 0 manually, or rely on the incoming message to have it. Anyway, right now we're just wanting to, I don't have a good way of putting a null character in the message though, with just socket server from the keyboard. So this uses pointer 0 also. And we're going to put this on row, we'll just put on 19. Oh, X. Oh, what? 10, 8, 7, 6, 5, 4, I think. So I was doing 10. I think it starts on 4, but that seems further than 4, but whatever. Okay, so that should print the message. Now, right now, it's nothing but, it'll actually automatically end in a 0 because the 6502 is clearing all the RAM. So we can just rely on that for now, I guess. Should work. All right. We need how many messages, how many characters was it? 15? 1 through 15. Yeah, 15. So that's how many bytes we'll get. Maybe we'll so our command really it's just 0. It's just an NRead. All right, so that's the message, that's the command. And we're just gonna sit in a loop. So we have to wait for the data to be ready. And this is not. So we wait, we send, we actually need to keep sending it. Let's LDY we have to keep writing 0 over and over again. So we'll wait for command STY, write the command, we'll wait for data, and then we'll read LDA ESP data. We want to use the Y register to index. Let's do this. So we load the command, it's 0. We write it. Now we can load the data. LDY 0 index. So this is the first store. We increment the index, we decrement the count. If it's not equal, we're going to read more data. So we're just going to keep doing that. Part of me says this could be like optimized. Because this is actually where the slow part is, between when you write the command and when the data is visible. But probably have to do some temporary store to support that. Let's just get it working first. So we write the command, we wait for the data, we get it. Store it. Okay. I think this might work. Maybe. Probably not. Give it a shot though. Waiting for it to wake up. There it is. 0 messages. The ESP says hello. Let's say send a message back at you. Well, we got something. Oh, you know what? It was not. Oh, it's going crazy. It kept fetching the data. Couple things going on here. It keeps fetching. We need to. So now we can try to do this. So this should message is read. It shouldn't. This next time it comes through, it'll actually always say 0 on the screen. To some degree, there's no point in printing it, but for debug for now. Now that message did not print properly. And it's because I've got everything ASCII char mapped. Actually, right, so when I say back at you ESP, I only have this multiple case and the things I'm able to print on the screen. I've somewhat limited myself to this character set. So let's, for now, only print capital letters. So A is 1E which is 41 hex. So I'm off. My offset is 41 23, hex 23. So if I want to print it, I actually need to decrement every letter. Really, I shouldn't be manipulating the data while I'm getting it, but I'm just going to go ahead and do it for now to prove that it's working. So subtract 23. This should at least get it working. Normally, if you had this character offset, like you'd want to apply that elsewhere or whatever, but not a bad first shot. Let's see now. Wait for it to wake up. Okay. Hello there, ESP. There's 0 messages. Now I need to type in all caps. I don't know if space is going to work right. Close. I think we wrote too much in one frame. Let me make it bigger. So I got yeah, some of the letters are wrong. I guess my string wasn't null terminated like I thought it was. It's let's just null terminate it. I'm gonna put these on the side because really these things I want to be removed. So we've already Let's try that. You see it still has 0 messages, so it appears that oh, you couldn't see me coding. Good job, Paul. Here's what I did. There's my ASCII offset. I just moved over, and then at the very end, I just add a 0 to the end to manually null terminate my string. Try not to leave you on that screen forever. Okay, it's awake. Says hello, and go. We didn't draw everywhere over the screen. So some letters we're missing the B. The space I'm not too surprised about because I was kind of expecting, because what is space is hex 20. We subtract 23 from that, we get -3 or whatever, which ends up being one of these tiles over here, which still looks kind of like a space, so whatever, it's fine. But our T back at, yeah, our T is messed up. Our B is apparently missing. Where did our P go? Why? I think we might have gotten more than 15 letters. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I'm actually sending the new line character. Anyway, I don't know why my T and my P and my B are missing. I wonder if we're not properly waiting for data. Let's look back at the code. Maybe I'm not waiting long enough. Yep, look at this. BWC. I'm supposed to be BR. I'm not waiting for the flag like I'm supposed to be. BR. If it's set, I'm waiting for it to go clear. Yeah, it's not present. Okay. So that's what happens if you don't wait for data. Sometimes it's there. Sometimes it's not. Which is interesting. I would have almost expected it to never be there. Well, actually, yeah, wait, I'm looking at the wrong code. Branch if the R is set. I was checking to make sure the W is clear. I guess that's almost equivalent. No, I don't know. Anyway, let's just see if we fixed it. Think we got it. Make it big. All right, it's awake. Hello, ESP. Back at you. Oh, you're not the ESP. You're the NES. Hey, we didn't miss any letters. We got but the B is gone. Did we throw away the first one somehow? I guess everybody's talking to the ESP though, huh? The middleman. So I wonder if somewhere I'm writing the command 0, but we got, when we did our test, we got all the data. So this is the last function we called. We're waiting for a reply, the number of messages, which is accurate. Waiting for the command, waiting for the reply. Then we call get ESP message. What happens if we insert an extra space? I mean, it's not a good fix, but why? Let's look at our Lua script. Yeah, we wrote command 19 and then we read 5000 and then we wrote 0 and read back. Let's just test it here again to make sure we're not crazy. Yeah, it's all there, as expected. Just wonder if the only thing that makes sense is the data happens to already be there. We load A. We wait to send the command. We write the command. I don't know. I don't. Oh, wait a second. Wait a second. This I don't think so, though. What I was going to say is this command is I write this command and then I'm waiting for a reply, right? Unless this is broken somehow. Is this right? It looks right. But the R bit is getting cleared here when we get the reply. So the R bit is clear, right? And then we call get message, and get message, I should make sure that's all 0. It should already be set. I'm just wondering if I don't know. I guess maybe pull out the logic analyzer or something. I don't know. Anyway, I think we're going to call it a day. Wait. 0, 1, 2, 3, 4. There's 4 bytes in the header of the message. So that's 1, 2, 3. It works. I was off, but I mean, I remember I was tinkering around with the lengths when I was testing on INLretro. And then I must have set the right length when I was testing again. It's good. We're good. It works. Hooray. So yeah, this is a recap of Stream 10 on February 21st. So we have a couple things going on. I'll power cycle the system here. So previously, the code, the NES code just started up and expected the NES to respond. Well, it actually takes a couple seconds for the ESP to start up. I might have just said some words wrong there, but the ESP takes a few seconds to start up. The NES needs to wait before it starts talking to it. So at power up, it starts sending a reset command, and it reads back that 1-0. It got the reset command back. Once it gets the A5 value back, so the 6502 keeps writing, hey, ESP, reset. Did you reset? It will know if it reset when the A5 value is read back. If it doesn't get A5 back, if it just gets the command back that it just wrote, then it's like, well, I guess that didn't work. I'll try again next frame. So it keeps doing that. There's no real timeout right now. Eventually code would want to have it and just be like, this chip ain't talking to me. Anyway, once it does, then all of our code from last time starts working to where I can push buttons on the controller and it sends the current button state to the remote, whatever we're connected to. But what we implemented, you can see here, once the ESP was sensed to be running, the NES sent a message and said, hello there, ESP. Now, we can actually send messages back, and this is how we do it. This is 4-byte header here. Has to start with an M, and then these are unused right now. So here's the message, back at you, NES. Now the 0 there, the A5, below the A5, that's actually the number of pending messages. Every frame it goes and checks and says, hey, ESP, got any messages for me? No? Oh, or how many? 0. So if we send this message, you won't actually see it because it'll end up getting cleared by the time it gets set. But before we had that functionality, it was working. So we can send it, and we get a reply, back at you, NES. So yeah, we send a message back and forth. There's a little bit of tomfoolery with the ASCII printing just because my tile set for the NES is, I have A aligned to tile index 1E. Well, that 1E is not ASCII. A is what, 41? So yeah, A is hex 41. So we're off. We have to apply an offset to get that right because I didn't put these in the ASCII values. I didn't because I using character maps in the 6502. Well, that's convenient, whatever, when you're writing all of your code in 6502, but when your messages are coming from the outside world in ASCII, that doesn't work so well. Anyway, it works. And spaces, right, don't fit that character map. It ends up using one of these down here for spaces. It still looks like a space, but whatever. So it still works to where if that first byte is the current state of the gamepad, if a button changes, it sends a packet of the current state. And controller 0 data, I don't know why that 6 is there, but controllers, the second controller data will show up over here. You can send the other controller data, write variable number 0 to F. If we send that message, there, 46. So F is hex 46, ASCII F. So yeah, we got quite a bit. All this stuff we implemented was mostly already supported, but we were manually punching all our data through the poke and peek registers up there. Now we have 6502 code that's doing it. We implemented our special commands, which have bit 4 set. In our interrupt service routine, if we get a special command, then we go ahead and call out to a different function to process those. So these might be a little bit slower because this function may not be cached in RAM, but it's not necessarily the most urgent of requests. So hopefully keep the interrupt service routine smaller in code size, but the length is still there. Now the slower commands, we have a bit for fast command. The slow commands will just set a flag and end up getting processed in the main routine. But ones that we want to try to get a response ASAP, like, hey, how many messages are there, that processes in the function. So yeah, we also implemented Lua script tests for these things, just because it's easiest to test this stuff with the INLretro first. Make sure that the hardware mostly appears to be working for the new routines that you write, and then go and write assembly with probably has bugs in it, and yeah. So that's what we got. You can see up here's our reset code. It just sends the command and then writes the current value. If it ends up getting the reset value back, then it'll break out of that loop. Otherwise, it just waits to the next frame and checks next frame. And here's our sending of a test message. So we use a pointer. This function expects a pointer. The first byte, well, it doesn't matter. We end up, Kudzu shows you can do Pascal style strings by having the first byte being the length, using Sterling in CA65, but that makes it just makes it convenient to call this function. We came to the conclusion this is the best way. So we load X with the number of bytes that you want to send, and then you set pointer 0 to the message that you want to send. So it makes sure it can send the command. Now this is a medium length message. which is up to 15 bytes with the length defined in the nibble. Ultimately, this will be less of a send a message, more of like set meta variables and stuff. Like we'll set the IP address and stuff like that. Anyway, we needed to get 6502 functions working for the basic things, and then we'll add complexity from there for yeah. So we just have a loop that writes data, keeps track of our count and our index, and pulls before writing each byte. And then our main loop down here is our message pull. So we just have a subroutine for sending command and then expecting a reply. And that's pretty basic. Just make sure that the W bit is set, which means that you're allowed to write to the data register. You write the command, then you wait for the R bit to be clear, which indicates that the ESP's response is in the register for you to read, so you read it, and that's it. So that we send the command to check for messages. If there's a message, then we'll display it. If there's no message, we'll jump over it, otherwise we'll get the message. Right, so we provide a pointer, we just have some RAM. We set the pointer 0 again to that. How many bytes do we want to fetch? We set it the X, and then we call get message. So we just use Y again, and here you just write the command for next, read next byte in the array. And spin on that, getting the data. So here's just where we put our hack to subtract the ASCII offset, just for now, to be able to see that we got the data we expected. And then we null terminate it manually here. These won't actually remain here, but for now, for this basic testing to print stuff to the screen, it's convenient. So yeah, we're getting there. Next time, I don't know, we still don't support longer messages, so for sending we can receive infinite length messages. But we only really support one message. Anyway, so maybe we'll work on that. You know, ultimately we have a conduit for sending and receiving data where we're putting or getting that data in the ESP. We want to make that more generic, so it's just like set a pointer to this virtual address or whatever, read or write data from there. Or maybe we have things defined as message, you know, read the most incoming message, stuff like that. Closer to what the types of abstractions that'll be most likely to be used. And it would be nice, I thought we might do it today, but we didn't really do it. I've got a local machine running. We can implement a server on, and Sylvan got me access to his VPS in France, so we've got a far one away to tinker around with too. That's not on my network because there's some curiosities about that. But yeah, I think surprise, surprise, I found Lua socket, which looks like the most reasonable, easiest access for me to start putting some functions on a server. To start, I don't really want to put much complexity in a server. I just want an IP address to go to find other, basically just a meeting room, a congregation of, oh, here's other NESs that are connected to the internet right now. Here's a list of, here's their IP address and the port that they're on or whatever, so that you can establish a peer-to-peer connection with them. You know, or eventually, you know, you could expand that server code to implement game logic there, or whatever, however that goes. But for now, my first goal is just to have a basic server that way you don't have to like chat with somebody on Discord or something like, hey, what's your IP address and your port? Like, it's just like awkward, like, no, log on, print it, see it, oh, what's their handle or whatever, and establish a connection with them. So yeah, thanks for everybody for tuning in, and we'll see you next week as we continue on.